Hello friends, welcome to C Field Academy for another video. Today's topic is stack. So we will discuss about the stack data structure as part of this video. So friends, let's get started. So as part of the stack data structure, these are the items that we will be covering today. So we will first start with an introduction and definition about stack. We will discuss what it is and where it is used generally, and some applications of stack for computer science. Then we will go ahead and see what are the operations that are available for the stack, which means we will see the push, pop and peek operations as overview. We will then go into detailed explanation for each of these operations. So we'll start with push first. We will discuss with an example. We'll also see the pseudocode, and next we will see pop, and then we will see the peek operation, which is an optional operation, and then we will move on to complexity analysis for these operations. And finally we will end with an exercise for you guys. So let's go ahead and get started with the introduction. So first of all, stack is a very simple data structure. It's not very complicated as we will see, like a binary tree or a graph wherein things are much complicated. But in fact, stack is pretty simple, and it can be implemented in a very simple way with very little modifications to the array. So stack is a linear data structure. Which means similar kind as an array, wherein elements can be accessed in a last in first out manner. So which means if there are elements will be stacked on top of each other, and only the element that entered last will come out. So the element that was in, that came in earlier will only get removed when the items on the top of it are removed. So examples of stack are, you can see a stack of cards over here, or a stack of plates, where the same thing applies. The plate on the top can be easily retrieved, whereas plate at the bottom can only be retrieved when all the plates on the top of it are removed. So stack can be implemented using an array or a linked list. So for simplicity, we will only see an implementation using array in this video. But if you know linked list, then you can easily translate the same algorithms or the same operations using a linked list. Then finally, there are many applications of stack. In fact, in computer science, there are various scenarios wherein stack is very useful. I mean, simple example is subroutine calls, which means when a procedure or a function call is made from one function to other. If you have been doing programming, you would exactly understand what it is. Then evaluation, expression evaluation, or detecting if an expression is valid, like you want to check if the parentheses are matching, the number of left parentheses match the number of right parentheses. Other applications include backtracking or the n-queens problem, and then a good amount of applications in memory management as well. If you would go into the operating systems book or operating systems topic, you would see there are various applications wherein we use stacks in memory management. Alright, cool. So how does the stack look like? So you can see a representation of stack here. So you can see a stack more looks like this, wherein two operations are only allowed, the push and the pop. Now there is a peek operation which is an optional operation, but push and pop are mandatory operation. So push indicates we are adding an element to the top of the collection if there is available capacity. So there would be some additional already existing items in the stack, and we want to add another item to the top of the stack. Then the next operation is pop operation. So pop operation removes the recently added item, which means the item that was on the top would be removed from the collection. Now in this case, if you notice, the item 3 was added to the collection at the top, and when the pop method is called, it would retrieve the element 3 from the stack. There is an optional peek operation which is similar to the pop operation, but it doesn't remove the item. It will just check the item and return the value of the item at the top of the stack. Alright, so these were the 3 operations that are possible or that are used in a stack. Now let's see how a stack can be actually implemented. So normally a stack is implemented using an array. We will see the implementation using array only in this video. So let's take an array, and we will take an array with a fixed capacity that is given to us. Let's say an initial capacity that we will call as capacity, and we will have a top pointer which actually points to the topmost element in the stack, or the latest element that was added. So capacity is the maximum possible size of the capacity possible. So in this case, you can see we have like 8 elements that are possible in the stack, so the capacity is 8, whereas top is pointing to the 6th element, which is 10, and top also actually represents or indicates the current size of the stack. So in this case, you can see there are 6 items in the stack. And then when the push and pop operations are executed or called, what we just need to do is adjust the top pointer. So which means we'll move the top pointer forward and backward to indicate the current size of the stack, and to execute the operations wherein we need to add a new element or remove an element. So let's see each of these operations in detail with an example and with some pseudocode. We will first start with the push operation. So first of all, to add or push an element, so the requirement is to add or push an element to the stack, a new element to the stack. So first we just need to check if we are not overrunning the capacity. So which means if the top is pointing to the end of the array, so top is pointing to the end of the array, we don't have any space for a new element, so we'll do nothing, we'll just return. Otherwise, we just need to increment the top to the next available position, which means the next position will increment it by 1 and assign the element to the new position of the array. So that's a very simple operation. Let's see this operation using an example. Let's say we have this stack over here which has 8 elements, and top is pointing to the 6th element, which is 10, and we want to push a new item which is 7 onto the stack. So what we will do is, the first step is we'll check if the capacity is there or not, and notice we have a capacity here because there are 2 spaces still free. There are only 6 items in the stack, and there are 2 items free. So we will then go ahead and increment the top pointer, so which means we will move the top pointer to the next one, and once we are done, we will push the item 7 or assign item 7 to the position that is the free position top is pointing to, and that's it. We just do it, and then top moves one space ahead, which means now we have 7 items in this stack. Cool. Let's see this pseudocode of the push operations real quick. Now that is also very simple pseudocode. If you have been following my videos till now, you will notice that this is pretty simple thing for you. So let's say we have a procedure push or an algorithm push which has a stack, which takes a stack, which means an array, and an item which needs to be pushed to the stack. So what this procedure will do is, it will push the item to the stack if capacity is available. So we are assuming initially stack is initialized with some capacity, which we don't know, but it's a variable, let's say, which is used to initialize the stack, and the initial top value is 0. So which means when top is 0, there are no items in the stack. So as we have already seen, the first step is to check if we have not overrun the capacity. So that's why what we check is we first check if top plus 1. So which means if we add 1 to the top, the next item that is space available is less than equal to capacity. So if that is true, then only what we do is we will go ahead and increment the top, which means we will do a top equals to top plus 1, and we will assign the item to the stack top, and then we are done. But otherwise, if we have run out of capacity, we just do nothing. In fact, we will just print a message called as an overflow message and just exit. Now let's apply this to the array which we had, or the stack which we had. So here is the array which we had. So this has a capacity of 8. We already discussed this, and currently top is pointing to the 6th element, which means we have 6 elements in the stack. Now let's add an item. Let's say we will add the item 7 to the stack. Now what will happen is it will call push with item as 7, and the first step it will check is top plus 1. Top is 6. We check 6 plus 1 is less than capacity, which is true because 6 plus 1 is 7. So we can add an element. So the first step is to increment the top. Top becomes top plus 1. So top now becomes 7. And then what we do is we do a stack top, which means we push the item to the stack. So we will move this item 7 to the stack, and then we are done. So that was about the push operation. Pretty easy, right? Cool. Now let's go ahead and see the pop and the peek operations. Now the pop operation, what is needed in the pop operation is to remove an element from the stack. In fact, remove the topmost element. So the first check we need to do is if there are elements in the stack, otherwise there is nothing to remove. So what we do is we check if top is pointing to 0, which means there are no elements. In that case, we just return null. We don't have an element to return, or we will return something like an underflow error. Otherwise, what we do is we return the element at the top, or we remove the element at the top, and then we decrement the top pointer by 1. So once we decrement the top pointer by 1, top now moves to 1 position less. So which means effectively what we have done is we have removed one item from the array. So this is how it looks like. Let's say we have an array or the stack wherein we have 7 elements, as we see in this case, and we want to remove one item, or we want to pop an item from the stack. So top is pointing to the 7th element, which is 7, and when the pop operation is called, it will remove the last item, or it will remove the topmost item, which means it will remove 7 from the array. So what we do is the first step is to remove or take out the element 7, and then the next step is to just decrement the top pointer by 1. So top now points to the 6th element, which is 10, and our job is done. Now a little different operation is the peek operation, which is pretty similar. It's just that we don't remove the item from the stack, but we just go see and then come back. We'll just return. So it's kind of a check to see which element is on the top of the stack. So sometimes this operation is pretty handy, wherein we don't need to remove the element but just check and see first and then do something and then only remove it. So in this case what we do is we just check first if top is pointing to 0, which means no elements are present, we return null. Otherwise we just go ahead, check the element and then come back, which means we return the element at the top. So we don't decrement the top pointer in this case. Alright, cool. Now let's see these the pseudocode for these operations. So first let's see for the pop. It's pretty simple. So what happens here is we need to pop an item from the stack if it contains elements, and it also assumes that stack is initialized with certain capacity, and initially the top value is 0, which means when there are no elements the top value is 0. Now here is the pseudocode. So as we already discussed in step 1, what we check is if top is greater than 0. In fact, if top is equal to 0 or less than 0, we don't have any element, so we'll just return null, or we will just print an underflow error. Otherwise, if there are elements in the stack, then step 2 to 4 is executed, which means we will first retrieve the top element and put it to item, then we will decrement the top pointer, and finally return the item, where we will be done with the pop operation. So let's say we have this stack over here, the same stack, and let's apply the pop operation to this stack. So the capacity of the stack is 8, and we have a top pointer which is pointing to the 7th element, and let's say we call the pop operation on this stack or on this array. So what will happen is, first step, as you can see, the check at step 1 will happen, wherein we'll check if top is greater than 0. Top is 7, which is greater than 0, hence this indicates there are items in the stack, and then we can remove the elements. So first step is item will be assigned stack top, which means item will now become 7 because 7 is the element on the stack top. Then top will get reduced to top -1, which means top will now point to item 6 or element 6. And finally we just go ahead and return the item, which means we'll just return item, return 7, and that's all, we are done. So that was the pop operation applied to an example. Now the last operation, which is peek. So pretty similar to pop, with just simple change that we do not remove the item. We get the item from the queue, sorry, from the stack, but we don't remove it from the stack. Now here is the algorithm for that. Here is the pseudocode for that. So we just check if top is greater than 0, which means there are items in the stack. We assign the stack top to the item, and we will just return the item. There is no need to decrement the stack pointer in this case. Now apply it, let's apply it to the array which we had. So capacity is 8 and top is pointing to 7, so we will remove the, or we'll get the item 7 and return it, but the stack top still stays at the 7th location. So that's the basic difference. So yeah, this was also pretty simple, the peek operation. Cool, I think we are now done with all the 3 operations. Now let's go ahead and look at the complexity analysis for these 3 operations which we saw. In fact, it's pretty simple because there's very little operations or very little tasks that are done in each of these operations. So first was push. If you remember, in push what we did is we just increment top, which means we move the top one element one location ahead and add the element to the top of the stack. So in fact this is just order 1, which means there is just one operation that was being done. Same thing with pop. With pop we remove the element and decrement the top pointer once, and hence this is also order 1. Lastly, with peek we only access the top element once, so even this is an order 1 operation. So in fact, in short, what we say is in any of these operations we don't need to visit the entire elements in the stack. It's just the top element that we are actually using to do our operation. Alright, so looks like we are done with the stack data structure. I hope you guys enjoyed this video. So before we end, let's see a short exercise for you guys. In fact, it's pretty short. So here is the first question. Now assume that we have an empty stack and then insert the following items in sequence: 5, 10, 12, 8. See how it looks like. Maybe even draw a diagram or a picture to see if that makes sense, to understand how items are inserted to the stack. Then go ahead and pop 2 elements out of the stack which we have now. So do it one by one and see which item comes out, what is the size of the stack and how the stack looks like. Lastly, a little complicated question which needs a bit of thinking, but I'm sure you guys would do it. We already discussed a little bit in the starting of the video. So think about how stacks can be used to check if an expression is valid by matching parentheses. So which means we are given an expression, a mathematical expression which contains parentheses, and we need to validate if the expression is a well-formed expression, which means in terms of the number of parentheses that it has. So think about how we can use stack to do it. And if you are able to think it, then here are three operations, the first, second and third, and try to see how we can use stack to see or check if these expressions are valid expressions or not. Alright, so that's all I had for you guys in this video. In fact, it was a short video. I hope you liked it. If you guys enjoy my videos, then please make sure to share, and if you have any questions, please put it down in the comment section in the video, and I'll definitely make sure to attend to it. Thank you guys. See you again in the next video. Bye bye.